Hey, so it looks like Edmentum has not fixed their first law of thermodynamics lesson. So I'm going to go over the questions dealing with that topic on the unit post test because I don't think it's fair to you all that they'll have stuff on the unit test, but they didn't post their lesson. So we're just going to go through 4 questions that deal with the first law of thermodynamics. And I uploaded videos that explain the topic and some key equations or things to remember about the first law of thermodynamics on our Canvas page. And I'll make an announcement about that later this week, but I'll show you a bit of that today. And the first law of thermodynamics is really the same as the conservation of energy. And that is because heat is a form of energy. And so in a system, that is conserved as well. And several processes that deal with heat transfer or work or things of that nature have different names. And one of those processes is called adiabatic. And that is when there is, get that out of my way, there is no heat flow into or out of the system. And I'll show you on my, here we go. So here's the Canvas page where I've posted videos about the first law of thermodynamics. Let's see. Yeah, it should be showing you the screen right now. But here are a few videos explaining that heat is a form of energy, and therefore, like other forms of energy, it is conserved. And this video is a bit more complex and shows you how we can use an equation to explain how much heat is being entering the system or leaving the system. But for that first question, we're dealing with the different types of processes that deal with heat and work and internal temperature. So if a process is isovolumetric, that means no volume changes, work is equal to 0. If the process is constant temperature, we call that isothermal. Iso means the same, thermal means temperature, and that means the change in internal temperature is 0. 3, no heat transfer, meaning Q equals 0. That is called adiabatic, and that is why our answer is, there we go, E, no heat flows into or out of the system. Adiabatic processes, no heat is flowing in or out, so Q, which stands for heat in our equation, is 0. Now this deals with that equation, and that is pictured here. Delta U equals Q minus W, where delta U is the change in internal temperature, Q is heat, and work is W. And it's important to remember when certain things are positive and negative. If a system is absorbing heat, Q, which stands for heat, is positive. If heat is being released from the system, Q is negative, all right? Heat, if you're gaining heat, you're absorbing heat, that's positive. If you're losing heat, releasing heat, that's negative Q. Work, on the other hand, is a little different. If work is done by the system, it's important to remember that term, by. If the system is doing the work, W is positive. But if work is being done on the system, W is negative. And in some cases, Q and W can also equal 0. But as long as you remember to keep your signs okay, you should be fine. So going back to this question, a thermodynamic system undergoes a process in which its internal energy decreases. Internal energy is delta U. U is internal energy. I believe I said internal temperature earlier, but that means internal energy. And we're all dealing with joules. So delta U is negative here, decreased by 500 joules. At the same time, 220 joules of work is done on the system. Now, if we go back, if work is being done on the system, W is negative, okay? Wrong window. Okay, so if we keep that in mind, we have negative 500 joules because internal energy is decreasing. The work is being done on the system, so that is negative 220 joules. What is the amount of heat transferred to or from the system? So if we take this equation, delta U, which is the change in internal energy, equals heat minus the work done by the system, we can rearrange that equation. Let me see. I'll share a whiteboard and maybe that'll, yeah, here we go. So I'll retype that equation. Delta U equals Q minus W. We know if we rearrange that equation, we can get Q by itself by adding the work to both sides. So delta U plus W equals Q. And then I'll just flip that equation around so it's easier to have Q on the left-hand side. So there we go. Heat is equal to the change in internal energy plus the work done depending on how it's being done. So we know that Q is equal to the change in internal energy. We knew that was, it decreased by 500 joules plus the work. And the work was done on the system. Remember, if the work is being done on the system, W is negative 220 joules. So the heat ends up being negative 720 joules. So if we go back to our question, let me get that out of the way. What is the amount of heat transferred to or from the system? Negative 720 joules. Okay. So which way is heat being transferred? It's being transferred away from the system, from the system. So if you go to this example, he has another example here. Let me see. Let me do a new share. Share computer sound. There you go. So here's another example.
Previously discussed. When doing calculations, make sure that you use the correct signs for these values, or the math will be incorrect. For example, if 100 joules of compression work is done on a system, and as a result, the internal energy of the system increases by 74 joules, how much of the energy is transferred as heat and in which direction? Let's take our equation and rearrange to solve for Q, which will be delta U plus W. Then we can plug in positive 74 joules for delta U, since internal energy increases, and negative 100 joules for work, since work is being done on the system. And we should get negative 26 joules for heat. This means that as 100 joules of work is applied to the system, only 74 go towards increasing the internal energy of the system, while 26 joules are lost as heat dissipates out of the system. These kinds of calculations will happen a lot in thermodynamics.
Okay, so hopefully that was another example you understood. Let's hide the floating meeting controls. Okay, so negative 720, that means heat is being lost in this process. The first law of thermodynamics is equivalent to which law or principle? It's like the law of conservation of energy. And then the heat added to a thermodynamic system minus the work done is equal to which of the following? Well, it's the internal energy. And that is just this equation. The internal energy is equal to the heat minus the work done by the system. All right. And that's it for the questions on the first law of thermodynamics. So hopefully that helped you out. Hopefully these videos give you a decent idea of what the first law of thermodynamics is. It's very similar to the law of conservation of energy. And then how to use this equation. Internal energy is equal to the heat minus the work done. And keeping your signs correct will give you the appropriate math. And that's all I have for you today. So I hope that helped. Good luck with everything. And I will give you an update if Edmentum fixes this. But until then, I will omit that assignment so it won't negatively affect your grade at all. All right. So have a great rest of your day, week, and I will see you guys and girls later. Bye-bye.